Sir, is it C?
It is C. Share me the approach.
So, what I did was first I assumed that the directions would be exactly opposite,
Mm-hmm.
and that wasn't giving me an answer in the options.
Okay.
Then I varied the 18 Newton force
Mm-hmm.
by with like 30 degrees and 60 degrees
Oh,
and took
good.
the horizontal component.
Nice. So you are thinking in the right direction, but that is unnecessarily consuming a lot of time. I'll give you a simple method. Ahan, any trick?
Well, I was literally about to do the same thing as Anushka.
Okay, fine, good. But let me tell you a shortcut. See, we have two forces here, 18 and 27, right? And now try to figure out if you have to find the resultant of these two forces. What is the maximum possible resultant which we can make out from 18 and 27?
9.
18, pardon, Ahan?
9, right? 27 minus 18.
No, that's minimum. For
Oh,
maximum, 18 and 27 should be in the same direction. So you add them.
so,
18 plus 27.
but
Yes.
it says in the question that they're acting in different directions.
Two forces act on no. That is fine. What I'm okay. Ignore this word as of now. Ignore the word as of now. We'll come back to that.
Okay.
Maximum possible. So this is a concept of vectors. Maximum possible resultant is when the two vectors are in the same direction. Same direction means you add them, right? And for minimum, we do the reverse. Minimum means the vectors should be in the opposite direction. That's why we do 27 minus 18, which is 9. So now remember, from 18 and 27, depending on what is the angle between them. So let's write down. The resultant maximum value is 45 and the minimum value is 9. That's the resultant force. So is it making sense so far, both of you?
Yes, sir.
Yes, sir.
Now, how do we find acceleration from force? Force is mass into acceleration, right? So let's write down 9 is less than or equal to ma less than or equal to 45. Mass of the object is 9 kilograms. So if we put m as 9 and simplify, we will get this. So the value of acceleration will have a range. It can be from 1 all the way till 5, depending on the angle between them. And now try to select an option.
Still C, that's the only one
It
that
is C.
falls within the range.
So this is the only option within the range, hence option C. Now, Ahan, since you mentioned different direction only means that the resultant cannot be 5,
Right.
right? So anyways, that is not in the options.
Okay.
That's why remember this range rule, maximum to minimum. Okay, moving on to the next. Try this. Okay, this is No calculations. What is Newton's third law?
Every action has an equal and opposite reaction.
Yes. So the forces should be equal and acting in the opposite direction. So which option satisfies that? At least some of the options you can eliminate.
Sir, is it C?
Explain.
I'm just going by the fact that there are two identical boxes.
Hmm.
And um, yeah, so the I don't know how to explain it, but the weight of the first box would be acting, or the normal reaction, sorry, would be acting downwards
Okay.
on the first box. That would
Hmm.
be 3, and then the box must also exert a normal reaction force on box number 2, which
Okay.
is 2. And since they're identical,
Answer
it,
actually is correct, but your reasoning is a bit on the other side. So, Anishka, can you tell me your logic?
Sir, I was confused between A and C, but
Okay.
now that it's C, I am guessing it's because force 3 is basically the upper box pushing on the lower box,
Hmm.
and 2 is the lower box pushing back on the upper box.
Correct. So, let us understand the logic. Newton's third law is equal and opposite forces. Let's go option by option. 1 and 2, okay, equal and opposite forces, and also write the two forces. Write this concept only. Newton's third law is equal and opposite forces where the two forces act on different objects. Okay, so Ahan, first tell me which of the options doesn't have equal and opposite forces?
1 second, I didn't, I got stuck on that option. Well, 2 and 4.
2 and 4. No, no, just looking at the picture, if I look at option A, 1 and 2, so you can see the forces are acting in the opposite direction
Opposite
and
direction.
also they are equal. So let's keep option A as it is. Now look at 3 and 4. 3 and 4, although could be equal, but they are in the same direction, isn't it? 3 and 4 cannot be. Now, C can be 2 and 3. 2 and 4. 2 and 4 again are equal and opposite. So technically, either of A, C, D could be the answer. But let us. Okay, so let's say you have the Earth's surface and we have a mass, let's say an object of mass m which is falling towards the ground. And okay, so Han, what will be the forces acting on this block?
Sir, mg downwards.
Mg downwards. Let's say there is no air resistance. So only mg downwards, right? But according to the Newton's third law, all forces are in pairs. So there should be a second mg somewhere. Where do
The
we show that?
the box pulling the earth to itself. So
Yes,
that
but where do I draw that?
um on the surface of the earth.
No, Anishka, do you remember? You have
Center
done
of the earth.
exactly. So if I draw the center of the earth, let's say C on the bottom, so the mg will be there. So Han, let me explain. So the block is being pulled by the center of the earth, right?
Yeah.
And that is this force mg. According to the Newton's third law, now the block is also going to pull the center of the earth by the same force mg acting in the opposite direction. So the two objects here are the block and the center. So this is constituting the pair. Forces acting in the opposite direction equal, and remember, forces are acting on the different objects. One is on the block, one is on the center. So does this make sense, Ahan?
Yes, sir.
Now let's go back to the question. Option A, 1 and 2. So, okay, Anishka, what does this force even represent? 1.
That's mg.
That's mg, right?
Ground pulling the box.
Perfect. So this 1 is mg. So according to the Newton's third law, the second mg will be on the center of the earth. It will be nowhere among these forces.
Even if it's stacked one on top of the other.
Yes, anything. If you are dealing with mg, the second mg will be on the center of the earth. It cannot be anywhere else. So 1 and 2 definitely are wrong. And with the same logic, you can also eliminate 4.
4,
4
yeah.
is also gone. So the only option left is C. Okay, great. So this was a good conceptual level question. Moving on, next. Next question is on the Newton's second law. Try this.